Welcome to Mission Tech Center videos. This time we are going to learn the term friction and a problem in connection with the friction. What is friction? Whenever a body moves or tends to move over another body, a force which is opposed to the direction of motion of the object is developed at the contact surface. This force is known as frictional force or simply friction. The main cause of the friction is surface roughness. It may vary with different surfaces. In the case of a smooth surface, the friction force will be 0. The term limiting friction is the frictional force when the motion is about to start. If the applied force on the body is more than the limiting friction, the body will move in the direction of applied force. What is coefficient of friction? The limiting friction is proportional to the normal reaction. This constant of proportionality is known as coefficient of friction. Consider a body of weight W placed on a horizontal surface. At point of contact, there is a normal reaction. If an applied force of magnitude P is given to the body, at the point of contact there is a limiting friction F max. This limiting friction is proportional to normal reaction, is multiplied by a constant . This proportionality of constant is known as coefficient of friction. The coefficient of friction has no units. The value of the friction will be always less than 1. Let us work out an example. Two blocks are given, A and B. An applied force of P is given to block B. Before starting the problem, you have to ensure one thing, that the given values are in weight. If it is given in mass or kilogram, you have to convert it into weight by multiplying 9.8. Then one important note is direction of reaction towards the body and direction of tension away from the body. The force is given to block B. Due to this force P, the body of block B will move towards here R2. Here also the direction of tension is away from the body. The directions of frictional forces can be measured from the block B, since the applied force is acting on the block B. Here the two contacting surfaces are making an reactions R1 and R2. Since the block will move towards right, the frictional forces should act against the direction of motion. Here it is mu R1 frictional force, here it is mu R2. We know that the direction of block B at the sliding edge is acting towards left. Therefore, in the case of block B, it will be opposed to that of. Now the free body diagrams are completed. We have to find the values of R1, R2 and P. For this, let's start the problem from point block A. Since block A having two unknowns, T and R2, for this, to draw X and Y axis, the tail of the force should be kept on the origin. Here mu R2 acting. Weight should be given in downward direction, and the tail of the force R2 should be kept on the origin. Applying equilibrium conditions along X and Y directions. In the case of Y direction, sigma Fi is equal to 0. Here, total upward force will be equal to downward force. That is, R2 is directly given. And in the case of sigma Fx, which is equal to 0, total forces acting towards right will be equal to left of the force, that is T is equal to mu r2. R2 is directly given. We know that 0.3 into 200 gives 60 Newton, which is the tension of the block A. In the case of block B, P is acting upward towards right, 300 Newton acting downward, R1 applying the equilibrium conditions in the case of block B, sigma Fy is equal to 0. That means R1 is equal to total applied force, upward force will be equal to downward force. Substituting value of R2, we get 500 Newton. In the case of x direction, applying the equilibrium condition, sigma Fx equal to 0. Thanks so much for watching the video.